Alright, moving on to question number 3 in the 2019 B test. This question is actually one of the more challenging questions in my opinion, but as always, please feel free to pause the video and try to solve it before I go over the solution. Okay, so the question is asking for the ratio of the potential energies U1 and U2. So we know that the equation for potential energy is 1/2 k delta x squared. Okay, so I'm just gonna write down these two equations. Okay, so obviously the ratio between these two is just going to be equal to k1 times delta x1 squared over k2 delta x2 squared. So all these answer choices are in terms of k1 and k2. So we want to find delta x and delta x1, delta x2 in terms of k1 and k2. How we do this is we have to first look at a fundamental property of this two-spring system. So from inspection, it appears that if you apply a force going to the right, obviously the spring constant, the smaller spring constant, which we assume is K2 because it's more spaced apart, something with a smaller spring constant will obviously stretch a lot more than something with a smaller, with a larger spring constant. So obviously the x1 and x2 depend on the spring constants. How do we actually find the dependence? Again, we have to use a fundamental property of this two-spring system. And that property is that, remember, if you have any connected string or rope, the tension in between all the molecules of the rope, all these tensions are the same. So we can apply the same concept here. All the tensions between K1 and K2, even at this junction between it, all the tensions are the same. So we know that the tension caused in this entire spring system is going to be K1 delta x 1, right? Because that's just the equation for the force of the restoring force of the spring. Specifically, this is the restoring force of K1. But this tension should also be equal to K2 delta x2, which is equal to the restoring force of the second of the spring with the spring constant 2. Because the tension throughout both of these structures should be the exact same. So that means the force of restoring should also be the exact same. So what do we see here is that we have K1 delta x1 is equal to K2 delta x2. So what I'm actually going to do is plug in x1. So x1 delta x1 is equal to K2 over K1 times delta x2 over it's just delta x2. So this is equation for delta x1. So I'm going to plug that in to this equation. And what I get is K1 times delta x1 squared. So that's K2 squared over K1 squared times delta x2 squared. Okay. So again, I'm just taking U1 over U2. Let's go to this. Divided by K2 times delta x2 squared. So these guys cancel out, and this one cancels out one of these, and this one, if we bring it up to the numerator, cancels out with one of these, so we are ended up with K2 over K1 as the potential energy ratio. So the answer is C.